The Nobel Prize is one of the most prestigious honors, if not the most prestigious. Yet the selection process is highly subjective. Is there a science to winning the Nobel Prize? I'll share with you what I've found from reading dozens of research papers, focusing on the most convincing analyses. I'll give you tips on where to get your training, where to work, who to work with, and where to get funding. This video covers the Science Nobel Prizes, as I don't know the science behind the Peace and Literature Prizes. And for the sake of completeness, I'll include the Economics Prize and Fields Medal in Mathematics as Science Nobel Prizes. Also, because the sample of Nobel Prize winners is very small, I'll also cite papers that study disruptive and high-impact research. First off, where you receive your training matters. Now I'm saying this not simply because we observe a correlation between the quality of a professor and the quality of their students, but because of a study of a tragic time in history. Shortly after Hitler rose to power, Jewish professors were expelled from German universities. At some universities, the mathematics department had no Jewish professors and were unaffected. Some mathematics departments had a majority of Jewish faculty, and therefore suffered greatly, especially because the Jewish faculty tended to be above average. At those universities, the Jewish expulsions lowered average faculty quality, and resulted in PhD students at those universities having worse outcomes throughout their academic careers, some of which stretched into the 1980s. This held even after you remove potential confounds, such as Jewish students, as well as the initial years of disruption. Now, there are many differences between Germany in the 1930s and any country today, but there are also many good reasons to pay attention to this example. In the 1930s, German mathematics departments were among the top in the world, and had scholars such as David Hilbert and John von Neumann. Also, the structure of mathematics was very similar back then. People attended conferences and published in journals. Even the content and style of recommendation letters were very similar to today. In short, all else equal, having a more productive mentor helps. However, I don't want you thinking the best mentor is always the biggest name at the most prestigious university. If you're in the running for the Nobel Prize, remember to select a PhD advisor that you can work well with. After you receive your training, who your colleagues are doesn't matter as much, since you are free to choose your collaborators, and your collaborators don't even need to be in the same country as you. Another study of the Nazi period found that the departure of Jewish professors did not affect their colleagues' productivity in various scientific fields. Also, a US study found that any positive productivity impact of being affiliated with a top 25 US economics or finance department had disappeared by the 1990s. Having said that, it's also good to work from new locations or multiple locations from time to time. When you do so, you get exposed to new ideas or novel combinations of ideas. Indeed, working in a new location or multiple locations significantly increases the probability that eventual Nobel laureates begin their prize-winning work in a given year. For example, Robert Lefkowitz began his Nobel Prize-winning work on G-protein coupled receptors in 1971, shortly after moving to Massachusetts General Hospital for a residency. Who should you work with? Obviously, you need to work with people that are knowledgeable and smart. When a superstar researcher passes away unexpectedly, their collaborators see a lasting productivity drop of between 5% to 8%. Beyond that, smaller teams produce much more disruptive work. Data from millions of research papers show that even when the same researcher works on the same topic in the same year in two different teams, one big and one small, the smaller teams search more deeply into the past, are viewed as more disruptive, and succeed further into the future, if at all. Larger teams are still valuable, but they tend to have a different focus, as they build on more recent and popular developments. Most researchers will need funding. Where should you get this from? The short answer is that you should try to find a funding source that will fund you, and not a specific project. In the United States, two sources of life science funding are the Howard Hughes Medical Institute and the National Institute of Health. HHMI programs support people, not projects. The award cycle is 5 years, and most awards are renewed at least once. As such, researchers can quickly reallocate resources to new approaches when the initial ones fail. In contrast, NIH grants last only 3 years, are tied to a specific project, and renewal after 3 years is highly dependent on project success. It's thus no surprise that HHMI investigators are willing to gamble more on creative lines of research. Indeed, HHMI investigators produce high-impact articles at a much higher rate compared to similarly accomplished NIH-funded scientists. They also produce low-impact articles more often, suggesting that they take more risk. Moreover, their research direction changes in ways that suggest the program induces them to explore novel lines of inquiry. This happens much less often with NIH-funded researchers. For example, NIH grant reviewers gave unanimously negative feedback on a project that later won Mario Capecchi the Nobel Prize. To summarize the signs of winning a Nobel Prize: train under good mentors, occasionally switch locations at various points in your career, work with a small and strong team, and find a funding source that funds you and not a specific project. And no matter what, make sure you have fun, because there is more to life than research and winning the Nobel Prize. Thanks for watching this video. I would love to hear your thoughts in the comments below.